Here we are for another video. Today I want to talk about single-pass or multi-pass plate heat exchangers. What does it mean? We are all accustomed to seeing in images and photographs of plate heat exchangers that have all four connections on a single front, specifically on the front side, on the front barrel, which is the part facing us. However, there are also plate heat exchangers that have front and rear connections. What does it mean? Usually these exchangers have a particular plate arrangement inside, a scheme called multipass, which means multiple passages. When is this type of multipass scheme utilized? It is utilized when we require extremely long thermal jumps and extremely strong temperature crossovers, typically in recovery plants. What is this for? It is necessary because in practice, with this trick, let's call it that way, we are able to extend the plates, meaning we have a much higher thermal length of the plates, practically double compared to the height of the heat exchanger. And this allows us to push the recovery, therefore the intersection of temperatures, to very high limits. Clearly, this trick comes with certain inconveniences, like the unavoidable increase in pressure losses that are bound to occur. It is also true that during the design phase, we can keep them under control by inserting them into the software and therefore compensate for the increase in load losses by increasing the number of plates or parallel channels. One of the events that occur on the sidelines of the use and installation of multipass heat exchangers is that we inevitably end up facing border attacks. This is not convenient and brings inconveniences. What occurs in essence? While we have no difficulty with front attacks, we can mount our valves directly on the flanged or threaded attack. On the rear attacks, if we mount the valves directly when we perform maintenance, we find ourselves in difficulty because we have the pipes obstructing our way. So we are unable to move the rear barrel, we are unable to remove the plates, and this hampers our overall workflow and efficiency. What's the trick? That of putting 90-degree curves and bringing the valves out of the shape of the heat exchanger. In this way, when we go to do maintenance, we intercept the valves, disassemble the curves, and we can easily move the rear barrel and do maintenance, open the exchanger, wash the plates, replace the gaskets. After operations, it's closed, curves and valves are reassembled, circuit is opened, and game is done. Another implication is that we can't make expansions without modifying the position of the pipes. The other part has something we have to bend to. I greet you, good evening.